Okay, so first thing I'm going to do, question 2, is to draw it out so I can add all the forces on. That's definitely the first thing you want to do. Always. A 60, and we got 2 meters, and then any extra info, that's 3 meters, isn't it? I'm going to add from the so the AB has weight 40, so that's A and that's B up here, isn't it? What have I put? That's C. So the action there, 40 newton, and that's 1 point. The beam is freely hinged. A, the beam's held in equilibrium, angle of 60. We've got that. AC is 2 meters. We got that. Okay, D is vertically above A. Fine. The rope is perpendicular to the beam. The rope is perpendicular to the beam. Yep, we've got that on there. Okay. Yep, that's fine. The beam is modelled to form and the rope is light and inextensible. And we want the tension in the rope. So hang on. That's the rope, isn't it? Tension's going to be there. So that to me, if that's 60, isn't it? 60. So that in there is going to be 30 degrees. So going up, we're going to have T cos 30. I'm just going to have a little. If we've got, that's 30, that's 60. Triangle, isn't it? 1, and that's root 3. So that's 60. Hang on, and that's 30. 60, 30. So cos of 30 is root 3 over 2. Okay. And I think that's everything. Consider resources basically on the beam that we get. Are there any other? Yeah, isn't there? There's a vertical reaction. That's AV. There's going to be a horizontal reaction as well. I'm going to draw it this. It'll come out as negative, but just RAH. That all the forces going on that affect the beam. There'll be some more forces up here, but we're just considering the beam, which is why we're just considering this tension as well. And we're going to want the horizontal component of this, which is going to be T sine 30. Okay. So forces vertically, we RAV plus T cos 30 is equal to 40, and we're looking for T. So what's RAV? Are we going to be able to get that? Forces horizontally. Well, we can see straight away that should be going the other way. We'll get RAH to T 30. Oh, I don't think this is going to give us what we want. So let's take moments about A instead. Now, this is T going up here, isn't it? And that distance there is 2. So if we go clockwise, and then, so we're going to have T times 2 is equal to, now there's 2 ways, the weight's going in the other direction, so that's going to be the other moment, and we can do it in 2 ways, can't we? We can work out, so that's the line of the direction of the force, and we can work out the distance between line of the force and the pivot. Let's do that actually. Why not? Why not do that? Okay, so That's going to be 30 in there. So that distance there is 1.5 cos 30. So when we take moments, the tension times the perpendicular distance, so T times should be equal to the 40 newtons times the perpendicular there, which is 1.5 cos 30. So 2T is equal to 40 times 1.5 is 60. Cos 30 is root 3 over 2. So that's going to cancel with leaving 30. And then is equal to 15 root 3 newtons. That's A. B. The magnitude of force acting on. So what we're looking for here is this. Well, RAV and RH. So I mean, it's not been wasted. So, well, let's get RH first. That's equal to T sine T. Let's write it out again. Which 15 3 sine 30 is equal to over H is a half times a half, which is going to be 15 root 3 over 2. And from let's call that 1 and that 2. So that's 1 from 2. Oh no, that's 2. So from 1 we've got RAV is equal to 40 minus T cos 30, which is 40 minus T is 15 root 3 cos 30 root 3 over 2. So that's going to be 15 times 5. Well, let's 82. So we can get 35 over 2. We can do a little. We want the result, magnitude of resultant force. So 8 is 50 over 2. RAV is 35 over 2. So that's the resultant. The magnitude. So M is going to equal to the square of 15 root 3 over 2 plus 35 over 2 squared, which is the square of what's that? 15 squared is 225 times 3. I'm going to use my calculator. 15 root 3 over 2 squared. Squared. Yeah. 35 squared 5 over 4 plus 675 4 grants, which is 5 root 18. Done. And what's it? If the rope was not modelled as being light, state how this would affect the tension along the rope. So if it's not light, it's going to be heavier at the bottom, lighter at the top. So tension would increase rope because of the weight of the rope. So if the fact that it is light means that you have constant tension. And there you go.